This lesson's on the Pythagorean Theorem. The sides of the right triangle have special names, and it's important to be able to identify and label the legs of the triangle. So your first step is always to look for the 90 degrees angle. So our 90 degrees angle is this right here, and that is signified by the square that is drawn. The next part from that is to look for your hypotenuse, which is going to be the opposite leg of the 90 degrees. So the opposite leg is going to be this portion right here, and that's going to be represent all of this leg right here. So that's going to become the C, which is the hypotenuse. And then from there, we're going to look for is our height and the base. Now, the most important part is the hypotenuse, the C. As far as the height and base, it really doesn't matter. We will go ahead and put base down here because it's on the bottom. So we'll go ahead and say B is for base down here. And so then all of this leg is going to be considered the base. And then from there, we have is the other leg, which is all of this right here. And that's going to become the A, which is our height. So that's the labeling of the right triangle, and knowing all of that piece is going to be really important to be able to use the Pythagorean theorem. Now let's look at example 1. We're going to identify and label the triangle. So I have put numbers on that triangle. We put 1 on the bottom down there. We have a 2 on the side. We have a 3 inside, and then we have a 4. Looking at this, which number represents the right triangle or 90 degrees? It is the 3 that's going to represent that. Which number on the triangle represents the height? It is 2 that will represent the height. Now let's look at the base. So which number on the triangle represents the base? It is number 1. Good. And finally, which number on the triangle will represent the hypotenuse? It is number 4. Now let's look at example 2, finding the length of the hypotenuse of the triangle. And so from the triangle, in example 1, we said we want to look for the 90 degrees. So our 90 degrees is right here, because the opposite of that 90 degrees leg will represent the C, which is the hypotenuse. And our C is labeled in this case right here, so this is good. And so then from there, our next step is then to label our A and B. So I'm going to go ahead and label this as my B, as my base, and then this is my A right here. Okay, now I'm ready to substitute each of those pieces into the Pythagorean theorem. So the Pythagorean theorem is A squared plus B squared equals C squared. So I know my A is 12, so I'm going to go ahead and put 12 squared, substitute that number. I know my B is 5, so we're going to go ahead and substitute 5 squared equals, and I don't know what my C is, so we're going to go ahead and keep that as my C squared. Now, when you do the Pythagorean theorem, please make sure you write it in vertical pieces of this as you do. It's kind of like the order of operations. As you do each piece, just kind of go down vertically, and so that way it's nice and neat, and also it will help you when you do your Pythagorean theorem. So let's continue on. So now the 12 squared, remember, as in our exponent, it is 12 times 12, and that's going to give us 144. And then 5 squared will give us 5 times 5, and that's 25, equals C squared right there. So we can add 144 plus 25. That will give us 169 equals C squared. And then the next part is we want to find what C is. So you will have to take the square root on both sides. So square root. And this goes back now to 7.1 lesson where we're finding the root. So in this, we would take our 169 and do a division ladder from there, and see what goes into 169. So 169, if you've never seen that number, it is actually a prime number, a larger prime number than the 2 and the 5 or even the 7 that we've used. So 11 will be the next prime number, but 11 times 11 is 121, so that's not going to work. And then 13 is our next prime number, and 13 times 13 actually gives us the 169. So since 13 is a prime, we're going to stop right there, and we're going to go ahead and put the 13 times 13 inside our radical sign equals, and then on this part right here, let's go ahead and take that c squared and take it as c times c right there. So that way you could see what is going to come out. So as we had said in lesson 7.1, we want to, this is a square root right there. So that's a power of 2, meaning I needed groups of 2 of the same numbers to come out of the radicand. So here's a group of 13 that's coming out, and you're having just 13. Remember, it's coming out. Literally, you do not have that radical sign anywhere there. And then same thing with this one, the c squared, and that becomes the c times c, and that comes out as well. So that's going to give us then c on this side. So then that becomes your final answer, is that c is equal to 13. Now let's look at example 3, which is finding the missing length of the triangle again. The first step is always to look for the 90 degrees right angle. So we have found it right here. And so the opposite of our 90 degrees leg, which is all of this piece right here, that's going to give us the C, and that is the hypotenuse. So if that's C and B is labeled on the base down here, so we're going to go ahead and label this as your A. And now we're ready to substitute all our pieces into the Pythagorean theorem. So A squared will give us then 16 squared plus, and we do not know what B squared is, so we're going to go ahead and leave it as B squared equals, and C we do know is 34, so we're going to go ahead and write 34 squared. Okay, let's work out the 16 squared. 16 times 16 is 256 plus, we don't know what B squared is, so we go ahead and write that out. And then 34 squared is 34 times 34, which is a large number, and that's going to come out to 1,156. The next step is to isolate B squared. We want to go ahead and subtract 256 on both sides, and that's going to give us then B squared is equal to 1,156 minus 256 will give us 900. Now we're going to go ahead and do our division ladder with the 900. So what is a prime number that would go into 900? We can use 3. 3 goes into 900 3 times, and that's a 0, 0. Is 300 a prime number? It is not, so that means we would have to do another round of the division ladder. So what goes into 300? Could be 3. So 3 goes into 300 100 times. Is 100 a prime number? It is not. What is a prime number that can go into 100? We can use 5. 5 goes into 100 20 times. And is 20 a prime number? It is not. We have to do another round of the division ladder. So what is a prime number that goes into 20? We can use a 5. 5 goes into 20 4 times. And is 4 a prime number? 4 is not a prime number. So what is a prime number that goes into 4? 2. 2 goes into 4 2 times. And is this 2 a prime number? Yes, it is. So we are done with our division ladder. So let's go ahead and put all of those inside our radical sign right there. So I'm starting with this 3 right here and listing them out. So 3 times 3 times 5 times 5 times 2 times 2 is equal to, and then the B squared, same thing, we're going to go B times B. Okay, we're looking for groupings, 2 of the same kind. So I see one group of 3 that will come out. I also see a group of 5 that will come out, and a group of 2 that will come out. Anytime we have groups that come out, the operation is multiplication. So we're going to multiply all of these. So 3 times 5 gives us 15, and 15 times 2 will give us 30. And then also on this side, we have is equals, and a group of B's can come out. So now we have B. So our final answer then is B is equal to 30.